Welcome to lesson 3-3. So the third and final lesson in activity 3 is called properties of rational and irrational numbers. And so what we want to do today is be able to determine whether sums are rational or irrational and determine whether products are rational or irrational. So we'll do a little problem to start, and then we'll talk a little bit about how we're going to determine whether sums or products are going to be rational or irrational. So to build a box kite, two members of the Windy Hill Science Club, Max and Beth, need to find the length of the diagonal crossbars of the kite's square base. Okay, so basically they want to find AC. Okay, now in question number 1, it says that AC is 20 root 2, and they want you to prove that. So if I use the triangle, it's a square, so I can use the right angle here for the triangle, make it a right triangle. I could actually use Pythagorean's theorem that says AC squared, so hypotenuse squared, equals the sum of the squares of the legs. So 20 squared plus 20 squared. And so AC squared, if I add the 400 plus the other 400, then I'm going to get 800. AC squared equals 800. Now when I take the square root of both sides to find the length of AC, I'm supposed to show that it's 20 root 2. Well, it's kind of easy to do that because I know the root of 800 just came from 400 times 2. Okay, and the square root of 400 is 20, so 20 root 2. Okay, so that's using Pythagorean's theorem. We were able to show that the length of the crossbar was 20 root 2 inches. Put inches in there since it's a real problem. All right, so now they kind of show you, they want you to know if this is rational or irrational. We have the two students that are going to argue about it a little bit. Max wants to know if 20 root 2 is a rational number or an irrational number. Max says that if it is a rational number, the following statement should be true. So he says that 20 root 2 should be able to be expressed as a over b, where a and b are integers and b is not equal to 0. Okay, so then we have Beth, and what Beth does is she says, well, let's divide both sides of Max's equation by 20, and we'll write an equation that's equivalent. So 20 root 2, if I were to divide that by 20, I just get root 2. And then a over b divided by 20 is a over 20b. So Beth says the new equation does not make sense. The expression a over 20b is a rational number because both a and 20b are integers. But she knows the square root of 2 is irrational because the square root of any number that's not a perfect square is an irrational number. So she concludes that Max's assumption that 20 root 2 is rational must be false. Okay, and now the question is, do you agree, or based on Beth's work, do you think 20 root 2 is rational or irrational? So hopefully you agree that it's irrational. And like she says, any square root that's not a perfect square is going to be irrational. So if you were to put it in your calculator, the square root of 2, you would see you get 1.414, and then it just kind of goes on. It doesn't terminate, and it doesn't have any special sort of repeating pattern as well. So we can see that, of course, we have an irrational number. Okay, on the next page, we have a different expression this time. It says Beth wants to see if root 5 plus 3 is a rational number. So she uses a and b again to represent integers and assumes that b is not 0. She says, okay, let's see what we can do with root 5 plus 3 equals a over b. Looks to me like she's subtracting 3 on both sides. So she gets root 5 equals a over b minus 3. Then what she does is she wants to be able to combine those expressions. So she used an appropriate form of 1, which is b over b. So she can actually do a minus 3b over b. Now, is a minus 3b over b the ratio of two integers? Okay, well that would be yes, because a and b are both integers. But does that make sense to you? I mean, is it possible for root 5 to be written as a ratio of two integers? We know the square root of 5 is approximately, that one's 2.23, and then it's like 6, 0, 6, 7. I mean, it just keeps going and it doesn't repeat. So we are not going to be able to write root 5 as the ratio of two integers. So we're going to have to say no, because the square root of 5 cannot be written as a ratio of two integers. Okay. So based on the answers to items 2 and 3, complete the following conjectures using rational or irrational. So the product of a rational number and an irrational number would have to be irrational. Okay, 20 times the square root of 2 would have to be irrational because the square root of 2 is irrational. Okay. The sum of a rational number and an irrational number is also irrational. Because again, the square root of 5 plus 3 must be irrational because the square root of 5 is irrational. All right, let's look at number 5. Let A, B, C, and D be integers where B and D are non-zero. Okay, it says show that the product of two rational numbers will also be rational. Okay, so if I have A over B times C over D, that's going to give me AC over BD. Okay, that's the ratio of two integers. That's what we need to get rational. Okay, that's the product. Let's see if that works also with the sum. The sum of two rational integers, doing the add is a little bit more complicated because we do need to make a common denominator. So the common denominator, of course, would be BD. And so if we multiply B times D, we also have to multiply A times D. And if we multiply D times B, we have to also multiply C times B. And again, we also get ratio of two integers. So we are showing that in both cases, the product of two rational numbers is rational, and the sum of two rational numbers is rational. So basically, two rationals will make a rational. A rational with an irrational will be irrational. That's kind of what this lesson is wanting us to show and to see. So let's take a look and explain whether or not we get rational or irrational based upon what we're given. So, little review from yesterday, when we multiply two radicals together, remember we multiply their insides together. So that's going to be the root of 35. Is that irrational or rational? Is 35 a perfect square? It is not. So we are going to say irrational. Okay. Part B, I have the square root of 2 times the square root of 8, so I'm going to multiply the square root of 16. But wait, the square root of 16 is 4. It's a perfect square. There we can say rational. Okay. So based on your answer to item 6, can we make a conjecture about the product of two irrational numbers? It's kind of hard to do because in part A, we got irrational for a product, but in part B, we got rational for a product. So it could be either rational or irrational. We really can't make a general conclusion on that. Okay, so it's kind of a short little lesson, just a quick review of rational versus irrational. Your Check Your Understanding question 8 has 4 parts, and then you have practice to do. So if you could work on 8 through 12 and highlight or star any that you need to ask for help on, and I will see you during Zoom to answer those questions.